Hello everyone, and I'm going to walk you through the setup for the Permeability Rate Lab, where we look at the sediment type and how it affects the permeability of water through sediment. And so I'm going to use 4th hour's second trial data because 4th hour is the only class that got to do a second trial, and then that way we'll all have the same data. So we're going to graph the second trial data first, and then you can go back and graph the data from your trial. 5th hour, just a quick note, I did mess up when we were setting up our graphs, so you'll want to grab a new paper and set it up correctly. Okay, so the first thing, we have our title, and really our title is the effect of whatever our independent variable is, and that's whatever is here in your x, okay, on your dependent variable, your y, and we're going to look at the calculated value y here. So really the effect of, and you have sediment type, go here, sediment type, on, I ran out of room, whatever your dependent variable is here, so that is permeability rate. Oops. Permeability rate. Okay. So now we're going to label our axes. So let's start with our x, which is this column here, which is also our independent variable, what we changed on purpose. So our x right here, we're going to write sediment type. Down here, sediment type. All right, and then on our y, okay, we are going to write permeability rate. So our x goes down here, and our y is going to go over here for our graphs, because again, we have our graphs are x and y. So here we're going to go permeability rate. So again, how fast the water was flowing. And the units that we use, you can see here, are centimeters per second. So we want to make sure we have that in here. It's not going to fit, but centimeters per second. For sediment type, all right, for down here, these are our different types. And what we're going to do, we're going to space them out. So I'm going to start here, and we're going to go every third one, we'll change our sediment size. So here's 0, 1, 2, 3, and I'm going to go from smallest to largest. So right here, this will be the first one, small sand. I'm just going to abbreviate small sand right here. And then next, I'm going to count 3 out. 1, 2, 3, evenly space them. And next, we're going to do medium sand size. So medium, and I'm just going to abbreviate medium sand right here. And then I'm going to space it out 3, 1, 2, 3. I'm going to go here. And now I'm going to look at medium gravel. Medium gravel. And then 1, 2, 3, and large gravel. And here we left some space here so we can make predictions about what would happen if we use larger gravel. And then we left some space here so we can make predictions if we used a smaller sediment type. All right, now we need to count our y-axes for permeability rate. So this is, again, 5th hour where I screwed up. I was looking at seconds, and I actually needed to look at the permeability rate because that's what we actually have to graph. So this is pretty close to 0, so we're going to have to start at 0, and it has to go up to at least 8.89 or 9. So actually, if we counted these by a half, each line is a half, then it's going to work out. So if I start over here and start at 0, and each line is worth a half, then this would be 0.5. And then I'm counting by half, so this would be 1.0. And then the next line would be 1.5. All right, and I'm going to go up by 0.5, and the next one would be 2.0. Now, I don't have to label every single line, so I'm just going to start labeling every other line. So this would be, this is 2.0, this would be 2.5, and then 3.0 centimeters per second. This would be 3.5, and then 4.0 centimeters per second, 4.5, and 5.0. I'm going to go, okay, next be 5.5, and then 6, 6.5, and then 7 centimeters per second, 7.5, and then 8, and then 8.5, and then 9. So we're going to the top of the scale. I wish we had a little extra room just in case numbers are different, but this looks like it's going to work. Now we're going to continue with a scatter plot. So with the scatter plot graph, we're just going to make a dot for our plotted points. So how we're going to do this is we are going to plot small sand, all right, and then your permeability rate. So just this and this is going to be your X and Y. So here, like it says, small sand there, and my permeability was 0.16. So here I'm going to find, and I like to use a ruler, my small sand line here, and this is 0.5, so 0.1 is like right here, okay? So that's my first plotted point. My next one's going to be medium sand, and 1.59. So 1.59 would be about somewhere there, and maybe here. And then I'm going to find medium sand, and then I'm going to make a dot for that. Next is medium gravel, so medium gravel in 5.4 centimeters per second. So now I'm going to go up to 5.4, which is just below 5.5. I'm going to find my medium gravel line and follow that up to where these two intersect. I'm going to make a dot. And then I have my large gravel. So large gravel right here. And then my other point is going to be 8.89. So I'm going to take my ruler up to 8.89, which is almost to 9, all the way to the top. I'm going to follow my large gravel line. And then I'm going to make, I lost my large gravel line all the way up here, and I'm going to make a point here, okay? This, and I'm going to do this. This is my trial 2 data. I'm going to do that in a color, and then trial 1 you can do in a different color, all right? So we can kind of see the difference kind of between there, but you're not going to connect the lines. Once you get all of them plotted, so from the trial that we just showed you and your data here, so you're going to be doing this and this. Then what you do, so you'll have some other points along here. I'm just making this up. Don't copy these. Ooh, that was big. So I'm just making up the data. Okay, and then, I don't know. All right. Then what you do is you take a ruler, and you don't connect the dots, all right, but you make a line that gets as close to all the dots as possible, and you don't even have to go through them all, or any of them for that matter. You just get as close as you can, and then you're going to draw one straight line that gets as close to all of them, okay? And that's called your best fit line. So when we do a scatter plot, that allows us to do something called a best fit line. And this is kind of a way of taking an average without having to calculate the average. And then this will allow us to make predictions about permeability rates of other sediments. All right, so go ahead and plot your data from the front, from your hour, and then use this data to help you answer these questions on the back. All right, email me if you have any questions. Thanks. Have a good one.